Hello everybody, Adam Lusick here, and today we're going to break down the multi-agent collaboration framework for LLM-based and agentic-based application development. So if you haven't seen it already, I have another video that goes over what agents are, how they work, and then also a different multi-agent framework, the agent supervisor framework, in this video that'll appear right in the top right corner for you right now. But today we're going to go over multi-agent collaboration. The main difference between them is that the supervisor is the one that's actually doing all of the routing of the work. However, in this one, we're just going to have independent agents working together on the same sort of document, same sort of task to complete the directed goal. To get a better understanding of the multi-collaboration framework, I've set up this very scientific diagram here in front of us. Essentially, what we're going to be doing is interacting with three individual LLM-based agents. One of them is going to have a weather searching tool that can search for current weather on a given location. Another is going to have an event searching tool that can search for events for a given location. And then the third is going to be a generic web search tool that they'll be able to query the web with any sort of thing that they want. Their task is going to be, what should I do this weekend? And so essentially what's going to happen is that's going to fall down first to the weatherman here, who is going to be looking up the weather and giving a weather report. It's then going to, all of that is going to get passed then to the event woman here in the center, who's going to be looking up the events for the given area. And then if we need to, we're going to pass it off to the third agent here on the right, who is going to search for the web for any additional information. And then this document is just going to be passed between them in this order and then worked on and added to collaboratively. And at any point, any of these agents can actually decide that we have all of the context necessary to finish the task and then return it back to me. More specifically, we're going to be following this diagram, which looks pretty complicated, but I assure you it's not too bad. All we have are the three different agents that we've got here: the weather agent, the events agent, and the web search agent. When the user sends an input, which in my case would be like, what should I do this weekend in Denver, Colorado? What events would be fun to go to? And where might I be able to park? It would first go to the weather agent, and then the weather agent will send a message to a router. And the router is very basic. This is not a supervisor. It's not even a language model. It's just going to take the message, and if the message is a tool call, it will route to the specific tool, which in the case of the weather agent is able to use the weather search tool, and that information will then be sent back to the weather agent. But if the weather agent just sends a basic message then back out, all of that work will then get passed to the events agent, and the same thing will happen. If the events agent calls a tool, that tool call will be executed. Context is sent back to the events agent. If it just sends a message, it will go then to the third and final one, the web search agent, and it will follow this loop back and forth across all of them until any one of them decides that the task is finished and returns the final output. So all this is doing is just handling all of the logic of actually either calling the tools or sending the messages and sending all of the context of the prior messages to the next agent in order, all in a loop until any one of them decides to finish. So let's hop over to the code and see how we can actually implement this in code. And so, of course, as always, going to be using a lot of LangChain and LangGraph to actually put this together. And much of this code is going to be augmented and taken from some of the prior documentation and the prior tutorials that LangChain themselves have posted. All of those resources will be linked down below in the description, along with the code that you're seeing here as well. And so to do this, we of course first need to format and set up the actual tools that we're going to be using. And so I chose to use three tools. The first one that we have here is the web search tool. This is an example of an already built-in tool in LangChain's package already. They already have everything built in to be able to work with DuckDuckGo search. So all I had to do here was do the API wrapper because I wanted to set a specific max results, and then feeding the API wrapper into their LangChain function of DuckDuckGo search run, we can create the web search tool right here. However, the next two are a little bit more complex because I wanted to actually define my own specific tools myself. And so what I did here is I created a weather and an event search tool. So let's actually dig into the APIs that I'll be using to set these up first. I found all of these APIs from just the public APIs GitHub repo, which is a popular, very popular, as you can see, repository that just lists out a bunch of APIs. And so I just wanted to find some quick ones, see what would come to my mind. And so that's really how this collaborative project came to be. But what I found was actually Open Weather Map, which has a free API for calling and getting weather data. And so for their 5-day, 3-hour forecast data, you're going to need, of course, the API key and then the latitude and longitude of the city that you're looking for, or of the area that you're looking for. So I'll have it linked below how to actually get this API key. But to get the latitude and longitude, you can use an additional API call that they have available, the geocoding API. And this is perfect because it can take in a city name and state code along with the API key and return accurate latitude and longitude. This is going to be extra useful as well for our second tool that we're putting together here, the event search, because this discovery API from Ticketmaster actually also takes the latitude and longitude. So hopping back to the code to see how we set these up, all I'm doing here is just very simply taking the API and converting it from just a regular API call like this into just a Python-based function using the requests package. It'll take the base URL, the parameters, and then we'll use requests to pass those all in. And then we just parse it all out into the relevant data that we want. And so that'll return as lat and lon. And then once we have this get lat lon function here, we can use it to get the specific weather data using the same requests conversion that we did before. And then we can get all that. And then I just have another function that parses the weather data here. So let's actually see a quick example of this with San Francisco. So as you can see, we're just getting the latitude and longitude, getting the weather data with that, and then passing in the API key, and then parsing it real quick. And so what we see here is that very simply, it will return a nice long list of all of these with the date, time, min temp, max temp, feels like, the weather, and humidity. Very similar to what we did up above with Open Weather Map. The Ticketmaster API is also free. I'll have that linked. And you can use the latitude and longitude and this discovery API to just get events in a specific radius. So nothing too fancy. I just have find events with latitude, longitude, radius, and a size of 50 so that it returns 50, using requests again here, and then parsing it very fast into this format so that we can just get some events. So similar to what we had, we now have 50 events in a 25-mile radius of San Francisco. These can be, of course, tweaked with all of the different parameters that we've got here that you can see here in the documentation, which of course I'll have linked below. But very simply, that's all that we'll need and all the functionality that I actually just want to return with the tools. So how do you actually take all of these functions and convert them into usable tools for the LLMs? That turns out to be really not too bad. And there's more documentation on defining custom tools here in LangChain's documentation, but all it requires is a name, a description, and an argument schema from a Pydantic base model. And so what we're doing here is we're first defining the schema in a class here with passing in the Pydantic base model, naming it weather input. All we're saying here is that we are going to need a city and a state. Those are both going to be strings. And then we can add a bit of a description too, so that the LLM can see what it wants. So for city, I just put like city name. And then for state, I just put state abbreviation and some examples. Exactly the same actually for the event input. I just had this schema called event input here. And then what you can do is use this tool decorator here, add in your name and add in the argument schema. And then everything past this tool decorator is what you can use to actually define your custom tool. So in this case, this function is going to be weather lookup. It's going to take in city. It's going to take in state. It's going to return a list. We add this description here because then the language model can actually see this description as well. So I have used this tool to get accurate weather forecasts for a city. And then all we do is pass it through a bunch of the above functions to return the parsed data from the weather. And then almost exactly the same for events. We pass all of that through the above functions to get the parsed data for events. And then with these decorators here, these tool decorators, we can then use these to bind them to the LLMs and make them all agentic. And so now that we have the tools defined, we now need to set up the actual agents themselves. And to do this, I'm grabbing some of the functions from LangChain's code here, which I have linked down in the description below of their notebook on multi-agent collaboration, and using a few of their helper functions to help make this an easier time. Essentially, they have a create agent helper function and an agent node helper function. This create agent helper function will take in the LLM, the tools, the system message, and format everything correctly so that it can be a nice agent that we can work with in a LangGraph setup. And it essentially goes as such. It will have the system prompt, which is you are a helpful AI assistant collaborating with other assistants. Use the provided tools to progress towards answering the question. If you are unable to fully answer, that's okay. Another assistant with different tools will help where you left off. Execute what you can to make progress. If you or any of the other assistants have all the information to answer the user's query, prefix your response with final answer so the team knows to stop. And generate a comprehensive markdown report containing all relevant information for the user question. You have access to the following tools, tool names, and system message. And then there's going to be a messages placeholder, which is where we're going to actually input the history and the conversation between all of these LLM-based agents together so that they can have all of the context from the user input and all of the actions that all of the other LLMs have done and all the different messages that are passed through. The prompt is then set up as such, and the tool names are passed through as this is passed through with the function, and all the system messages are added in here. And then with the prompt, we bind the tools to the LLM using the LangChain bind tools function, and then it'll return this agent. And so very simply also, the agent node function is what we're going to be using to help when we create the LangGraph node for a given agent. That's just going to take in the state, the LangGraph state, which we'll be defining here, the agent that we just made, and then the name of the node. And then the results is going to be actually invoking the agent and getting the output of it. Then all that this is doing is going to be taking the message and formatting it in a sense that we can put it back into these messages placeholders and accurately and effectively be able to pass all of these messages along to each agent in the loop. We'll get into actually using these right after we set up the state, so that'll be a little bit more explained here. But first off, of course, we need to create the LangGraph state that we'll be using. And the state is essentially all of the information that is going to be passed between the agents and all of the information that the agents can actually affect. And this one's going to be very simple. All it's going to do is take the messages, which is just going to be this. As the agents produce a message, it's going to be added into this list here of messages. And then it's also just going to update who sent the last message here and the sender. So this is going to be passed along. So each concurrent agent is going to know who sent the prior one, and then all of the previous messages they're going to be able to see and then add on to in this loop. So let's actually use all of this setup to create the agents. And right now, just for demonstration purposes, the LLM that I'll be using is GPT 3.5 Turbo, but this is how we're going to be using the different helper functions to actually create the agents and then the nodes that we're going to string together. Using this create agent function, we see that it takes in the LLM, the tools, and the system message. So we pass through the LLM, GPT 3.5 Turbo, the tools, which in this case, the weather agent is going to be the weather lookup tool, which we defined up here, weather lookup, perfect. And then the system message. So right now I have, you should provide accurate weather data for the other agents to use. When you have provided weather details, pass along the work. And so all of these create agent functions are essentially the same, except for the events. We pass in events and say provide accurate events data. And then for web search, I just have use the provided web search to give accurate results for the team. And then all of these functions using the helper function, super quick and easy way to set up the agents and binding the tools to the LLM with the accurate system message. The LangGraph node then that will correspond to this agent, we're going to use a partial function using the agent node function here. And then we're just going to pass through the weather agent and then the name, which is weather agent here. So that'll do all of this nice stuff of actually making it into a LangGraph node that we can use for setting up our graph. The final thing that we'll need is, of course, a way to handle the tool calls. So LangChain has this built-in tool node that we can use. And all we need to do is put in tools and a list of all of the tools. So these are the three that we're using, and then pass those into this tool node function. So a little bit more on that is available here in these links. We're almost to the point where we can actually compile and make the graph here to visualize, but all we need is that central routing function here. So this router. So that is not too bad to set up. It's very simply just going to be this function. It's going to take in the state, which is, as we mentioned up here, just all of the messages and the sender. And what it's going to do is it's going to look at the last message. If the last message is a tool call, it's going to route to the call tool node, which is going to be our tool node here. However, if it's not, then it's just going to go to the next. But if the last message has final answer in it, it will return end. Else, it will just continue forward in the loop that we set up. So putting this all together, we're going to compile it using LangGraph. So of course, we're going to pass in the agent state that we defined above into the state graph function from LangChain. And the agent state here is what we have here for the LangGraph state. And then we're going to add all of the nodes we need. So we have the weather agent, the events agent, the web search agent, and then the tool node. So all of these are here with their names, and then the node that we defined earlier, the tool node here, and then weather, events, and web search that we have here. And then we need to actually add in all of the logic of how they can talk to each other. So our entry point here, which I have set defined here, is going to be the weather agent. And so then from the weather agent, it's going to do its thing, and then it's going to call the router. If the weather agent just puts out a message, it'll go to the events agent. If it goes to call a tool, it'll go to the tool node. And if it has a message that says final message, it will actually end the whole flow. So if it does just continue, then it'll go to the events agent. The events agent will follow the same thing through the router function. If it has a tool call, it'll go to the tool call. And of course, the tool call here, we have this quick lambda function that will actually just send the information from the tool being called right back to the respective agent that called the tool here. So that's what's actually going on in the tool node. But if it calls the tool, it'll go there and then come back. If it just puts a message, then it'll continue on to the web search agent. And then you're starting to see where this is going. The web search agent then will either call a tool, which will get the information and go back, or write a message, which will either continue on back to the start of the weather agent, or if it has final message, it'll end. But adding all of these conditional edges using this router logic that we have, we can put that all together, set the entry point as starting with the weather agent, and then compiling it all. So essentially, we've built and put together this. So it'll go to the weather agent, and then we see that that message is passed to the router. If it's a tool call, it'll call the tool and then go back straight to the weather agent. Else, if it just gives you a message, then it'll continue on to the events agent, so on and so forth in this flow until one of them has the final message. A little bit more complicated view, we can actually use this function to get a mermaid chart. And so this is what it's actually showing us as the mermaid chart here. I tried my best to make this as not complicated with the initial graph that we saw, hence why I didn't flash this lovely looking mermaid chart at the beginning. But essentially we have all of the routing and all of the logic put together. So now we can actually test it out. So to do this, we'll just be using the graph and streaming it, starting it off with a quick human message here. And what I'm going to put here is, what's the weather? What fun events are currently happening in Denver, Colorado this weekend, June 1st through 3rd? Also, can you search where good parking might be? And so let's go ahead and run this and follow along. So immediately we see the weather agent gets that. It goes to call a tool. It calls the weather tool, which gets all the weather. And then the weather agent goes on and gives a little bit of a blurb about the actual weather. All that is a message. So then that message is passed to the events agent. The events agent looks at this and says, we don't know no events. Let's grab some events. So it uses the tool, the events tool, and calls it, gets all this. That is then sent back to the events agent. The events agent then goes on and is like, okay, here are some cool events. That's the message. The message is then sent to the web search agent. The web search agent then calls the tool and actually looks up where parking might be. So that's great. It then spits out some stuff here, and then it sends it back to the weather agent. The weather agent didn't really do anything here, and so it just passed it off to the events agent, but the events agent was like, yep, we've got everything we need. Let's get the final answer. So it spits out this final answer here, and we see that June 1st, we've got the weather. June 2nd, we've got the weather. June 3rd, we've got the weather. Here's everything fun to do, I guess, just on June 1st. And then here might be some good parking locations. So as you can see, this is just the work being passed between all of the different three agents that we defined here. The agents have a choice. They can either call or just generate a message. They can call the tool that they have or generate a message. And then any one of them can actually decide. We saw here that it went all the way around back through the weather agent, and then only the events agent decided that the final answer was found, and so returned this, which I just have a quick little bit to format. And so as you can see, this is really cool to see because it's essentially three language models collaborating together using the tools that they have, but all working together and passing the work along to sort of solve this final task or my final query that I had. However, this comes with a lot of downsides as well. A lot of the pros is that this is a very dynamic workflow. This is all fully based on language model based logic to both attack a task and also determine when the task is finished. This can provide very unique, very interesting results, and it's cool to see this being sort of, fully automated and passed around. However, the same thing that makes it cool to watch and cool to see also provides very heavily to the cons of this. What I've seen is that sometimes the language models have a hard time figuring out when to invoke their tools, or the language model might even try to invoke a tool that's not even bound to it and then throw an error. Other things that I've seen is it can loop kind of endlessly. So we already saw this, and thankfully this first thing that we tried, this first query, went actually really perfect, but we did see this redundancy, that all of this information was passed to the weather agent, and then the weather agent, all it said was, I've provided the weather forecast for Denver, Colorado, yada, 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 and some good parking locations. If you need more information or assistance with anything, please let me know. Like, that's not what we're looking for. The events agent here is the one that finally figured out, oh, we've got everything. Let's provide the final answer, summarize it all in nice markdown form according to my system prompt. So it can start to actually get caught in this loop where it'll just go round and around, and none of them want to say that it's the final thing or do the final stuff. They just say that it's like, I have provided this information. It's good. Not actually sort of having a clear end. As such, and since all of this logic is being handled with the language models, it's not super controllable and it's not, consistently reliable. Let's go ahead and try and run this one more time and we'll definitely get different results. So let's check this out. We see that the weather agent calls the weather. The weather agent says, well, as you can see, the weather agent calls the weather again. And so then it gets the weather again. And then finally it goes to the events agent. So that's one redundancy that we've seen. It looks at the weather twice. The events agent calls the events. That's cool. Events agent says it's cool. And then the web search agent actually goes, well, all this is cool. And then it should go back to the weather, wow, okay, actually. No. Oh, here we go. The web search agent used the call tool, then passed off the message. And then the weather agent put everything together, but it didn't say that it was the final message. So actually it's going to go back to the events agent again, which will then give us the final message. And as you can see, a little bit different from our first one. But some of the things that we saw here is, of course, again, this weather agent not figuring out that we have all of the necessary information here and passing it along one more time. Also, for some reason, the weather agent called the weather tool multiple times when something like that really wouldn't need to happen. So while this is very dynamic and super cool to see and watch them all collaborate, it's not as, I feel, reliable as the supervisor setup of having a supervisor agent hierarchical setup, or just setting up your own very specific LangGraph flow, like what I've done in some of the things like my Llama 3 research agent and whatnot. Nonetheless, this is a really interesting idea and a really interesting way to start approaching language model-based and agentic-based applications, and it's certainly worth looking through and understanding how different agents can actually handle this, handle the tool calling, and work together to actually solve a problem. All of the code is, of course, going to be available with additional resources down in the description below. If you thought this was cool, leave a like. If you got a question, ask it in the comments. All else, hit that subscribe button. Thank you.